All right, welcome back once again to the fourth day of our review. This is the last day. If you're doing this, it means we are finished with everything for geometry for the year. All right, which is a good thing. It also means maybe that you need a little bit extra help on this Kahoot, so that's what I'm here to do for you. All right, so we're going to cover some volume and stuff that we did towards the end of the year, so it should be good. First thing, goes back to the beginning of the year though, the number of vertices. So we're going to find the following in the figure. Now, we did faces, edges, vertices. This is one of the first lessons we covered. Now, in case you forgot, vertexes, or the vertices, are where two lines meet. So if you have two lines, the point that they touch, where these two fingers are meeting, is your vertice. All right? So in this case right here, there's a bunch of places where the sides meet. 1, 2, 3, 4, 5, 6 of them to be precise, where the edges meet. So there's 6 vertices. Next one is faces. Faces are the flat, or the two-dimensional sides. So that would be, a face would be like my TV screen, like your top of your desk, okay, like the edge of your phone, that'd be a face. So those are the faces of your things. That'd be the actual sides, okay? Those are two-dimensionals, and those are usually polygons. So in this case, you got the right side, 1. You got the top, which is 2, the front and the back, which is 3 and 4, and the bottom, which is 5. All right? Problem 71. The edges. The edges are the actual lines. That's the actual lines that where the faces meet, okay? So if you had a box, that would be the edges of the box, okay? So it's where, watch this, the black turns blue. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, you got 3, 3, 4, 5, 6, 7, 8, 9. All right. Now, the way to find this is you use Euler's theorem if you want to check your answers. The edges plus 2 equals the number of faces plus vertices. So 9 plus 2 is 11 equals 5 plus 6, which is also 11. All right? Next one. Now we're going to do some volume problems. First one is the volume of a triangular prism. Now, the way to find the volume of a prism is you take the area of the base, and the base of a prism is the side that's congruent. So you have two sides of a prism always, and those two sides are always the same. In this case, it's triangle. The way you can figure it out is whatever word this says. So in this triangular prism right here, we have to find the volume of these triangles. All right? And then we're going to multiply it by the height of the prism. The height of the prism is the distance between the two bases. So triangle's area is 1/2 base times height. Base and height of a triangle, not the hypotenuse. The hypotenuse is the longest side. So we don't even use the 26. So half of 11 times 24 is 132. So this is 132 square units. Got it? All right, so we're going to multiply that by the distance between the two bases, which is 64. 132 times 64 gives you 8,448. All right? Easy peasy. All right, we're going to do another one. Number 73. Another right triangular prism.15 again, base times height. 10 times half of 10 times 11 is 55. Distance between the two is 15. Now you may be saying, why aren't these h's the same? Well, this is the height of the triangle. This is the height of the prism. All right, the height of the prism is not included in the triangle ever. Okay. Problem 74, find the volume of the rectangular prism. So you can do this the same way. You can do 3 times 12, find that, and then multiply it by the height, or just use the straight up formula, which is length times width times height. Length, width, height. So 12.5 times 12.5, 469 cubic units. Right? Units are cubed for volume, squared for area, and they're just by themselves for linear distances. Right? Find the volume of a sphere that has a diameter of 26. The formula is 4/3 pi r cubed. So first thing you have to do is find the radius. Radius is half of the diameter. So half of 26 is 13. Now you just take your 13 and you're going to cube it. 4 divided by 3 times pi times 13. And on your calculator, you're going to do a little caret and a 3. And it gives you your answer of 9,203 cubic centimeters. Right? Got it? I didn't put the units, but this should say cm3. Find the volume of this cylinder. Volume of a cylinder is pi r squared h. So pi Radius here is 3.5 squared times the height, which is 5.5. 211.7, and this symbol is feet, so it should be cubic feet. All right. Number 77, find the area of the white region in the circle, not the yellow. We did this last lesson, or last time. The measure over 360 times pi r squared. Now the measure of the white area is not 136. A circle is 360. So it's 360 minus 136. So the area of the white part is 224. So 224 divided by 360 times pi 7 squared equals 95.8. Right? Square units. Got it? All right, let's go 78. What is the measure of angle RS? RS is the angle down here. All four of these angles add up to 360. So, and the 360, x plus 261 equals 360. All right. Subtract 261. Get 99, which is 99 degrees. Right? Any questions? There are, email me. All right, 79. How many common tangent lines are there? Well, 1, 2, 2. 3. So there's 3. In case you guys forgot what a common tangent line is, a common tangent, well, a tangent line is a line that hits a circle in one place. If you have two circles, a common tangent line is a line that hits both circles, each in one place. All right, so it hits each one of these circles in one place, each one of these circles in one place, each one of these circles in one place. All right? Write the standard equation of a circle with a center of negative 5, 8, and a radius of 7. Do you remember the standard equation of a circle? X minus h squared, this is back from chapter 10. Y minus k squared equals r squared. So your center is hk, your radius is r, and you're going to point xy on your graph. Now, in this case right here, hk, radius is 7. All right, so what do? X minus 5 squared plus y minus 8, your h and your k, equals 7 squared. All right. X plus 5 squared plus y minus 8 squared plus 49. That's it. If your center is a negative, you put it down as a positive. If it's a positive, you put it down as a negative, and you square your radius. Easy. Halfway there. 81. What is the image that is produced when ABC is translated using the following vector? -3, -5. So I'm going to take this vector. If I go -3, I'm going 3 to the left. So obviously A is bad and B is bad, because those move the figure to the right. -5 moves 5 which way? 5 down. So obviously not C. Answer has to be D. That's an easy one. Which of the following letters have at least one line of symmetry? A line of symmetry is a line that cuts a figure in half, and each piece that it cuts it into is identical. So it's just a reflection of itself. So for instance, if I had a rectangle and I cut it down the middle, I could fold the rectangle over and there'd be no overlapping pieces. So right here is A. I could draw a line of symmetry right down the middle. I could fold this over and it would look the same. R, no line of symmetry. J, L, if it was a lowercase l, yes, but not a capital L. B, B actually does. You can cut a B like this and fold the top of the B over. What about H? H does. You can, actually, H has two. You can fold it over and you can fold it up and down. Okay? So that is symmetry. The line of pretty much reflection. I drew the line of reflections. Right? All right, A3, what is the measure of our angle ABC? Now, if arc AC is 108, how do we find the angle? The angle is, do you remember? Half the arc. So the inscribed angle right here is half the measure of the arc. Okay, so half of 108 is 54. Right. 84. If a point is selected at random in the figure, what is the probability that it will land on the unshaded region? Unshaded region is this region right here. So say I just drop something at random. What's the probability? Do you guys remember how to do probability? Oh, we want the unshaded over the total. It's like a percentage, right? So what do we want of the unshaded or what do we want of the total? Well, we can find the areas. So the area of the unshaded part is length times width. Or sorry, of the purple, the shaded portion, 18 times 25 is 450. The area of the unshaded portion, 10 times 13, is 130. Now, area of the unshaded is 130. Area of the total is 450. So the probability that it lands here is 0.29. And anytime you want to turn it into a percent, you just multiply your decimal by 100, 29%. If I ask for the probability of it landing in the shaded region, I would just do 450 minus 130, which is 320. 320 divided by 450, and that would equal 0.71 or 71%. All right, and the two should add up to it. Got it? 85. Oh, this is another one of my favorites. Tennis balls with a diameter of 2.5 inches are sold in cans of 3. If the can is a cylinder, what is the volume of space not occupied by the tennis ball? All right, pretend it's part of Bob's spot. So first thing we got to find is volume of the cylinder and the volume of the tennis balls, which are spheres. So we know cylinder volume is pi r squared h. So we need the height and we need the radius. So the diameter of the tennis balls here are 2.5 inches. So we can use that. So if the diameter is 2.5 inches, can we find the radius? Half of that, which is 1.25. All right? So I know it's 1.25 from the center of the cylinder to the outside of the radius. So now I have pi 1.25 squared times, but what do I do to find the height? Anyone? Well, the diameter of a ball is 2.5, and how many do I have? 1, 2, 3. So 2.5 times 3 is 7.5, which is my height. So volume is 1.25 squared times pi times height. 36.8. Now, volume of the tennis balls. Volume of the sphere, 4/3 pi r cubed. 4/3 pi 1.25 cubed. How many tennis balls do I have? 3. So I take my 8.2 and I multiply it by 3 for the 3 tennis balls. And that gives me a total volume of tennis ball of 24.6. Now, how do I find the amount of space in between? What do I do with these two numbers? I subtract the 2. Give me 12.2. All right? You good? Awesome, awesome, awesome. Almost there. The wheels on a scooter, we just did this one, have a diameter of 4.5 inches. All right? And 85, that's cubic inches. I gotta get better by writing down my units. The wheels on a scooter have a diameter of 4.5. So circumference is pi times diameter. Diameter is 4.5, so it's pi times 4.5 inches, right? So it's 14.1 inches is the circumference, all right? Distance equals revolutions times circumference. Distance, we don't know. 150 revolutions times 4.1 inches is 2,155 inches. I don't know. Turn that into feet. Divided by 12. And you get 176 feet. That's more reasonable to know that, right? That's about almost 2/3 of a football field. Not quite. 176 feet. Yeah. Right? You good? All right. Almost there. Find the area of an equilateral triangle with a side of 12 inches. All right, so equilateral triangle. Means all the sides are the same. So I have a triangle, 12 inches, 12 inches, 12 inches. I want to find the area. So I have to find the height of this triangle. How do you find the height? Remember, I am going to put draw a triangle over here and here. Remember we did this? Half the bottom is 6, hypotenuse is 12, and our height is 8. So what do we use here? A squared, b squared, c squared. All right, Pythagorean theorem. 8 squared plus 6 squared is 12 squared. 8 squared plus 36 is 144. 8 squared is 108. H is 10.4. So the height of this equilateral triangle is 10.4. And what's the base? 12, not 6, 12. So it's half of 12 times 10.4, 62.4. And it's 62.4 square inches. All right. Next one. Find the diameter of a sphere that has a surface area of 36 pi square inches. Now, surface area is different than volume. We don't really cover surface area too much in this class anymore, but here's the formula, so you should be able to use it. We just do it with spheres. 4 pi r squared. So 36 pi equals 4 pi r squared. 36 pi divided by 4 pi. 36 divided by 4 is 9. Pi divided by pi is 1. So your answer is just 9. 36 pi divided by 4 pi, 9. R squared equals 9. Square root both sides. R equals 3. So the radius is 3, but it asks you to find the diameter. So the diameter is 2 times the radius, so it's 2 times 3. 2 times 3 happens to be 6 inches. All right. Now, I threw on some bonus problems on here, too. Aren't you lucky? Let's go some bonus. Almost forgot to do the trig. So, trig. Turn your calculator into degrees. All right. So, you have your hypotenuse. Looking for x, which is your adjacent. So, you pick which one of these. Adjacent hypotenuse is cosine. So, we're going to use cosine angle equals adjacent over hypotenuse. Cosine 53 equals x over 13. Since the variable is on top, 13 times cosine 53, 7.8. Calculator in degrees. Mode degrees. All right, good. Next one. Trying to find x here. Opposite, adjacent. Tan. Tangent x equals 22 over 35. Since we're finding the angle, you're going to use the inverse second tangent button, which is tan negative 1, 22 over 35. Hit enter, and you get 32.2. Calculator in degrees. Ready for the last one? Let's type. All right, here's your angle. Opposite, hypotenuse, sine. Sine 20 equals 7 over x. Since your variable is in the denominator, variable goes over here. Sine 20 goes over here. You pretty much cross multiply. 7 divided by sine 20. You get 20.5. Right? Boom. Last part. Area of a regular polygon. How could we not do this? This is one of the best parts and one of the hardest ones. And they give you a little difficulty. Area of a regular polygon equals 1/2 A, which means apothem, little a, not big A. P, which stands for perimeter, which is however many sides you have times the side length. Since it's a regular polygon, all the sides are the same. So let's do the first one, a regular dodecagon. Dodecagon is how many sides? 12. If you don't remember that, count them all. All right. What's your apothem? 10. All right. So, perimeter first. Perimeter equals number of sides 12 times each side length is 4 is 48. Your apothem here is 10. You're just going to type in 48 and 10 into this equation. Half of 10 times 48 is 240. See? Not difficult. Last question of the review. Regular octagon. Octagon is 8 sides, right? Each side length is 15, which is a perimeter of 120 units. Apothem. Which one is the apothem? The apothem always goes to the, where? What do you think? Apothem's 20. The apothem always goes to the center. All right? Well, actually, this 10 should be going here, not here. This should be slid down. I don't know how it got moved. The apothem goes to the midpoint of each side. All right? This should be actually going there. Whoops. All right, so half of 20 times 120. 10 times 120 is 1,200. All right? The thing that goes from the center to here is your radius, which you don't need unless you're using Pythagorean theorem to solve for your apothem. But you're given your apothem. And once again, this should go here. Anyway, that is the end of your reviews. That covers everything you learned this year. Hopefully, when you take the final, you do very well on it. All right? Or if you're just looking back on this to get a little bit of geometry stuff that you forgot, maybe, helps you out. Or if you don't even take the class and you just watch it, learn some geometry, awesome. All right, anyway, so moving on to bigger and better things next year. Probably what? Pre-calc, trig, stuff like that. Algebra 2. Good luck. Till next year.